Let's look at an example. So this is a field with only two elements, the two essential elements, 0 and 1. Let's draw its addition table. We know that 0 plus anything would give you back the element. So 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 1 is 1. But what about 1 plus 1? Okay, I'm telling you it's 0. Okay, why is that? Let's see if 1 plus 1 is not 0. Let's see 1 plus 1 is 1. Okay, what does this give to us? If we have this, we can add the negative of 1 on both sides. Okay, and you can put those two together, use associative law. Okay, and this will give you 0 plus 1 equals to 0. And this will give you 1 equals to 0, which is impossible, okay? Because every element in the field cannot be equal to the other element in the field. So we know that 1 cannot be equal to 0, so 1 plus 1 has to be 0. The multiplication table looks quite similar. I mean, it should be simple since we only have two elements. So again, 0, 1, 0, 1. 0 times anything is 0. We proved right here, okay? So 0, 0, 0. And 1 times 1 will give us 1 because it's additive. What is this called? Additive identity, okay? So A times 1 is A. Well, 1 times 1 will give you 1. Another proposition, if f equals to 0, 1, a, b is a field, notice that this has 4 elements. Okay, this proposition is specifically for a 4-element field. If you check the other propositions we talked about, those are just fields in general, okay? So this one is talking about if we have a 4-element field, let's say 0, 1, a, b, then a times b is 1. This proof is quite important because this proof shows you the proof of elimination, which is a proof that you will be using most of the time in fields. So we know that a times b, it has to be closed under multiplication, which means a times b is either 1, 0, or a or b due to closure. So let's suppose a times b is 0, okay? So this, if you multiply the reciprocal of a on both sides, again, you can only times both on the same sides, okay? Not one on the left, one on the right. Has to be the same sides. So you multiply the reciprocal of a on both sides, and eventually you should get b equals to 0, okay? Because this will give you 1, this will give you 0. And 1 times b is b, which is 0. I didn't specify what I used for each step because I did it before, so I didn't do it here. But when you try to prove anything in this part of the course, you should specify which axioms you used and do not skip steps, okay? Do not skip any step. Really important. So don't do this. I'm doing it because I'm making the video so I can explain each step to you anyway. So we know that b cannot be 0, which is This is false, which means a times b cannot be 0. So let's suppose a times b equals to a. Again, you do the same thing. You multiply the reciprocal of a on both sides. And eventually you should get b equals to 1, which is impossible again. So a times b cannot be a as well. The third one is if we suppose a times b equals to b, this time you multiply the reciprocal of b on both sides, and you should get a equals to 1. Again, this is not possible. So a times b cannot be b. So we know that it cannot be 0, cannot be a, cannot be b. Okay, so our only option would be 1. This is why a times b can only be 1. Okay, so this elimination method is quite important. Wait, hold on. Elimination. It's really important. Make sure you know how to do this kind of questions. Okay, examples. So we have a field called F, and A and B are in F. And they're saying that if A plus C equals to A plus B, then C equals to B. So if you look at this, you would say, oh, this is simple, okay? That's it, C equals to B, okay? We cannot do that. You cannot skip any step. So let's do this proof. Assume that A plus C equals to A plus B, okay? And suppose C, no, we cannot use C. Let's see, suppose W plus A equals to 0, which means W is the negative of A here. Okay, so we can add W on both sides. Because I want it to be add with A, that's why I'm adding it on the left side. Okay? And I'm gonna use associative law to add them together. This will give you, okay, because W plus A equals to 0, so this will give you 0 plus C equals to 0 plus B. This is additive inverse. Okay, and we know that 0 plus C is C, 0 plus B is B. This is because 0 is the additive identity. Okay, therefore C equals to B, and we're done. Okay, so this question seems really simple, but make sure you don't skip any step. Do not skip step. And make sure you specify axioms used. Okay, those two are really important. Highlight here. That's the key of this chapter, okay? Next, proof. Suppose A is not 0 and A times B equals to A times C. Then B equals to C. Okay, so those two questions are essentially the same. It's just one is addition, the other one is multiplication. Again, suppose A is not 0 and AB equals to AC. Also, let's suppose W is the multiplicative inverse of A. So let's write it as W times A equals to 1. Okay? Now we can multiply W on both sides. Again, has to be the same side. And use associative law. Well, it's essentially the same thing. This will give you 1. This will give you 1. This is because it's reciprocal. 1 times B is B. 1 times C is C. This is because 1 is a multiplicative identity. Okay, and you are done. Okay, so this is my proof. Can you see if there's anything that's missing? Okay, this question is a bit different than the last question. Something is missing in my proof and I want to add to it. Because we have this, okay, because we know A is not 0, that is why W exists, okay? So we need to specify that. Okay, let's add to it. Since A is non-zero, the reciprocal of X exists. And we let W equals to the reciprocal of X, i.e. this. Okay? Now you can use it. But this is really important. Really important. You need to show these words. That is why I wrote it in red. Please remember this sentence, okay? Alright, conclusion. What can we conclude from what we did here? What I'm going to do is I'm gonna give you another table for 4 elements field. Okay, for this one, let's play with multiplication table. First of all, 0 times anything is 0. So this row and this column should be easy. Okay? Also, 1 times 1 is the multiplicative identity, so this row should be easy. Alright? Also, what do we know? We know this is true. We know this is true for 4 element field. So we know A times B is 1. So A times B is 1. A times B is 1. Okay? What is left is just right here. We don't know what this is. We don't know what this is. Okay? The key to do this is play Sudoku. Did I spell it right? How do you spell Sudoku? Okay, I don't know how to spell. Just play Sudoku. Pretty sure you know how to play. So, for this row we have 0, A, and 1. Nothing can be replicated, so you can not put 0 here, not A here, not 1 here. The only thing left is B. Okay? Okay, so this will be B. And here, the only thing can fit here is A. Okay, so that is our multiplication table for 4 elements filled.